Hi everyone, my name is Brian and today I'm going to show you how to install one of the most popular, if not the most popular, packet analysis tool ever. So what you want to do is navigate to wireshark.org. Alright, and once you're there, go ahead and select download, and what you'll see is a few different options. What I recommend is to install either the 64-bit, assuming you're using a modern computer, or 32-bit if you're behind. I don't recommend using the portable apps unless you know what you're doing. Most of the people I've worked with have attempted to make portable apps work without realizing that they need additional tools for the portability. So yeah, if you don't know what you're doing and you want to avoid having a headache or being tedious to others, yeah, please do download the 64-bit version. So I already did this, and what I am going to do is I am going to go ahead and launch the installer. So in my toolkit, and I go to my setup files, I have the Wireshark installer. So I am going to go ahead and double click this, and we're just going to go through the setup portion of this. So first thing, typical installer, hit next. Noted, yep, I agree. Alright, default are good, so unless you know exactly what you're doing, just hit next. Same here. I suppose you can change this, but you know, definitely if you want this to work right away without having problems, just do the defaults. Alright, I'm going to pick my directory. Yep, that works for me. I installed npcap earlier. So if you don't have, or I'm sorry, if you're installing this brand new, go ahead and install npcap. You will need it. If you don't install it, your life will be more difficult. So I will go ahead and select next here. Alright, USB pcap. This is specific for capturing packets related to USB devices. It's typically not commonly used, and whenever I use Wireshark, I use it specifically for network analysis and not really USB analysis. So you can leave this unchecked unless you have the need. So I will go ahead and select install. Alright, and after it extracts these files and places them into the proper directory, we will then have Wireshark installed. So this shouldn't take too long, assuming that your system has the resources for it to run. Alright, it's almost there. Alright, perfect. It finished. We will just hit next and finish. So this application doesn't automatically launch itself after its completion. It doesn't really need to, but if we want to run the tool, it's just in our Windows installation folder, or I'm sorry, our Windows program folder. So I'm just going to hit the Windows key. I'm going to type Wireshark. There it is. It's an app, and I am going to go ahead and launch this. Okay, so this is what the Wireshark interface looks like, and by default it might look cryptic to some people, but it's really powerful, and once you understand where things are, it's really useful. So what I'm going to do is I'm going to mouse over this interface here, my Wi-Fi, just so I can get an idea for what the IP is that I'm using. So in the bottom right we see 10.1.10.35. Oops, it just went away. 10.1.10.35, which tells me the IP address of the interface that is currently capturing this data. And the reason this is important is because if you are on a VPN, you might have a bunch of different interfaces that are capturing packets simultaneously, so you want to be able to distinguish which one is actually the one where you can see the real data on. So I'm going to go ahead and I'm going to open up Chrome here, and I'm going to open up a command prompt as well. All right, and I'm just going to get this command ready. So I'm going to type netstat -an, and I'm going to do find string TCP, only because I know that with the netstat command, it's going to output all of my active sockets, and I'm going to look specifically for the TCP packets. So let me just run it without really quick. So netstat -an, pipe it to more, enter. So it tells me the connections that are currently listening. So with that, I'll go back to find string TCP. All right, we'll make it a little bit more legible there. So there we go. We see some connections. If there's too much output, just redirect the output to more so you can page through what you're actually trying to see. So I'm going to open up a new tab here, and I'm just going to go to yahoo.com. All right, I went to Yahoo. Now I'm just going to go to more. I'm sorry, I'm just going to hit my command. All right, so I see my listening ports, but what I am concerned about are the active sockets. So these are TCP connections to an SSL site or HTTPS site using one of the random ephemeral ports. So what I see in this is I see my IP address 10.1.10.35, which tells me that this is the proper interface to capture data on. A quicker way to do this, assuming you only have one interface, or you can also do ipconfig/all find string and just do IPv4. And that's another way to kind of distinguish what your active interfaces are. So all that to say that this Wi-Fi is the proper interface to use. So what I'm going to do is I'm just going to go ahead and double click this. All right, Nichiyobi Sunday, perfect. All right, and I see some packets that are traversing my network, but no, this is not super exciting for me. So I'm just going to go ahead and refresh my Yahoo page. All right, so now we see more data, and I don't know how much of this I should go into, but I'll just give you a basic rundown. So this top pane here is known as the packet list pane. These are where your list of packets are and will show. The middle pane here is known as the packet details, which shows you the different layers of your OSI model up to where the protocol is stacked. And then the bottom is your packet bytes, and for the most part I hardly ever need to use this for troubleshooting anything. But what I want to do is I want to see what happened on my DNS. So I'm just going to type DNS to filter out my DNS packets. Alright, and I did do a request to Yahoo. So what I can do is I can do Control F to bring up my find dialog, and then change my display filter to string. So in terms of computers, a string is just, that's a string. This is string. It's just kind of like a word, and I don't know if spaces are used. But anyways, I'm searching for Yahoo. All right, perfect. So what I see here is I see the request to Yahoo, and I searched in the packet list pane, which is this pane here. Now let's just say I want to find something else. Let's see, what's a good one? Okay, so if I wanted to find csc.beep.bc.yahoo.com, csc.beep.bc.yahoo.com, what I would do is, paste it here, but this first drop down is extremely important. So packet list will only search the top pane, this section here. Packet bytes, which you will likely hardly ever use, will only search the bottom pane here. And then packet details will search all of these in the middle pane. So everything that has a colon is known as a header. So let me just do a search and see what we get. Packet details. csc.beep. Did I type something wrong? Okay, I'm just going to simplify it a little bit. Okay, yep, I typed it wrong. So anyways, it brought up the query that was done. So this wasn't something that I typed and said, I didn't type csc.beep.bc.yahoo.com, but what happened is that whenever I requested yahoo.com, Yahoo itself had these other elements of their website that were part of my initial GET request. So I'm just going to type HTTP, clear this out, and oops, let me try HTTPS or TLS. Here it is. Okay, so this is a little bit of TLS stuff. I don't want to go into it too much, but let me see if I can find that packet that we requested. I'll just use this one. So okay, I'm just going to filter out some of this. So TLS dot record dot content type equals 23. So I'm going to negate this. You can kind of guess the string of the display filter based on where it is located in the header, because as I'm typing, it auto completes a lot of these fields for me, and really just experience and just doing this on a lot of occasion is kind of why I know this. So I'm going to negate tls.record.content_type, which references this application data here. So this is the content type. So if I do this, this whole packet list thing would be cleared of the application data, because for me, I can't read what this means. It doesn't mean anything to me. Alright, so I negated this, but I want to focus on TLS again. So I'm going to do an AND condition. So an AND condition is created by using 2 ampersands and then the protocol name, which is TLS. Alright, so here we are. We're ignoring the application data because it's just such a mess to dig through, and we're only searching through the TLS protocol. And in this client hello of the packet, let's see, we want to look for the server name extension, which tells us the name of the host being requested. So this is just one way of using Wireshark. If we want to be more crazy, we'll just right click on the client hello, we'll follow it, we'll follow the TLS stream, and it will show the 3-way handshake, the SYN packet, then we have the SYN ACK, and then we have the ACK. So yeah, this is just the basis of a 3-way handshake, SYN, SYN ACK. And then after the 3-way handshake has been established, the subsequent packet is going to be whatever protocol is going to be negotiated that sits on top of TCP. So in this case, it's TLS. So client hello is like, oh, we got data, great. And then the server hello, change cipher. So that's basically the way that that you can kind of use Wireshark, and I might go over this some more some other time. But yeah, just so you get an idea, hopefully these filters can help you some. So yeah, good luck with Wireshark, and maybe one of these days I might talk more about troubleshooting.